Your application can be vulnerable, even if every single line of code you wrote is perfect. The risk hides in the dependency your app relies on, and in the dependency of those dependencies. Before we get into GitHub security features, we need to understand what dependency vulnerability actually is, and how it can turn into a real problem for your app. Let's start with a simple mental model. Imagine you have a Node.js web application built on top of a framework called Express. Your app depends on Express. Express, in turn, depends on many other packages. Now, if any of those lower level packages has a non-vulnerability, then Express effectively inherits that vulnerability. And so does your application. The risk bubbles up through the chain. So, when we talk about dependency vulnerabilities, we are already talking about potential problems that live in the building blocks your app is assembled from. Most ecosystems already give you a way to scan for this locally. In Node, the standard tool is npm audit. When I run npm audit in this project, it inspects all my dependencies and points out a list of non-vulnerable packages, along with their severity information. We can see multiple high severity vulnerabilities reported here. That doesn't automatically mean my app is exploitable, but it does mean there are known issues in my dependencies tree, and I need to understand whether my usage of these dependencies is affected or not. So, what does it actually mean? When a package is flagged as vulnerable, most tools give you a direct link to the security advisor. Let's open one of them. The advisory describes a potential denial of a service issue. Specifically, certain inputs can trigger a stack overflow or cause extremely high CPU and memory usage, effectively crowding out resources and taking your application down. The advisory also tells you which methods are risky, and it tells you how to fix it. Sometimes that means updating to a safe version. Here the fix landed in version 120.3. Sometimes you also have a configuration option to prevent dangerous input from triggering the bug at all. Here is a takeaway. A flag vulnerability doesn't guarantee your app is exploitable. It means there is a possibility of a problem, and you need to check whether your usage matches the vulnerable scenario described in the advisory. So far, we have only looked at Node, but modern systems often use multiple languages and frameworks. Without any central help, every ecosystem brings another tool you have to learn. One for Erlang, one for JavaScript, one for .NET, another for Python, another for Go, Swift, and so on. And for each of those, you would need to figure out how to find the vulnerabilities, how to track them over time, and how to make sure they are actually resolved. That gets hard very quickly as the number of repos, languages, and team grows. Thankfully, if your code lives in GitHub, you don't have to stitch all of these together by hand. Here's something worth knowing right now. These local tools, they actually pull their vulnerability data from the GitHub advisory database. So, GitHub is already under the hood. The next step is using GitHub built-in tools to see all of these in one place, across every language, every repo, and every team. In the next video, I will show you the GitHub dependency graph, how to see exactly which packages your project relies on, and which ones are putting you at risk. If this was useful, hit subscribe and check out the next episode. We are moving from local tools like npm audit into GitHub, and it's a much cleaner picture. See you there.